Hello, this is Ms. Bader with a video on describing properties of graphs for precalculus and honors precalculus. So we're going to discuss several properties today: domain, range, end behavior, continuity, increasing, decreasing intervals, and then extrema, absolute maximum, absolute minimum, and local maximum and minimum. If you want to pause this video now and copy the graph and copy any parts of what you see that you want to work with, you may do that. Okay, so let's start out with domain. So we're looking at what is the domain of this function. So the domain is all of the x values in a function. So we're really reading the graph from left to right. So from left to right. And one way I do this sometimes is I take a pencil and just drag it across the page to see where the graph touches, right? So if I do that, I do see that I have a graph all the way up until -3. And then there's a break in the graph. -3 is not actually a part of the graph. Whenever you see a dashed or dotted line, that indicates something about the graph, but it is not actually a part of the graph. So -3 is not part of our domain. There is a discontinuity here. Then we pick up again right after -3, and all these x values are covered. And then we have a break or a discontinuity in the graph again at 3, right? So in addition to -3 not being part of our domain, +3 is also not part of our domain, right? So then the graph picks up again and continues forever. So what I can say about my domain is that it includes all real numbers, but x is not equal to 3, and x is not equal to -3, and x is not equal to 3. Okay. Another way you can write that is -infinity to -3, -3 to 3, and then 3 to infinity. It's just another way you could write that if you wanted to. Right. Range is all y values. So for your range, you're reading the graph from bottom to top. So we'll start, sometimes the way I like to do that is now put my pencil horizontally and move up or down to see what parts of the graph are covered. So we're going from -infinity, we do see that there are y values covered here, covered here, covered here, covered here, and so forth. So we actually don't have any y values that are excluded from the function. So we're going to write all real numbers, or we could write -infinity is less than or equal to f of x, sorry, is less than, not less than or equal to, less than infinity. So you can write it either way. Okay. End behaviors are what is happening as the graph, as your x values get very, very big and very, very small. So what we're going to say is, as x approaches -infinity, f of x approaches something, and as x approaches +infinity, f of x approaches something, right? So this basically means as you go left forever, right? Left forever, what is y doing, right? So if you look at this graph and you go left, right? So you're going left forever, forever, forever. It looks like your y values are snuggling up to 0, right? You're getting closer and closer and closer to 0. Maybe there's an asymptote there, we're not sure, but from the graph, it appears that f of x approaches 0. Now we're going to go to the right. So as we go right forever, continue, 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 it looks like, whereas here we were approaching 0, here the graph is decreasing. It's approaching -infinity. So here, as x approaches infinity, as we go right forever, f of x approaches -infinity. We go down forever. So that is end behaviors. For continuity, really, if someone asks you if a graph is continuous, that's asking for the entire domain. If I had asked you continuous on a certain interval, that's a different question, but the graph is not continuous because of these breaks that we talked about at -3 and 3. So we're going to say it's not continuous. Okay. All right, so increasing and decreasing intervals. So here we will take a look at where the graph is increasing. So I'm going to go ahead and say, as you read it from left to right, you have this interval is increasing. This interval is increasing. By contrast, if you look over here on the other side, here we're now decreasing, right? We're going down, and here we're decreasing, we're going down. So it looks as though there are 2 increasing intervals and 2 decreasing intervals. So for increasing, we'll go from -infinity, right? Because that's the first part of the graph. And the arrows indicate that the graph, the domain continues for -infinity. So from -infinity to 3, when we have that break, to -3, when we have that break, it is increasing. And then again, we pick up from 3 to -1, right? So -1 is sort of where the graphs changes directions. Right. And now we'll take a look at our decreasing intervals. So our decreasing intervals are going from -1 to 3, and 3 to infinity. Okay. All right. Last section, we'll talk about extrema. So extrema refers to what's called the absolute minimum. So the highest y value on the entire graph, the absolute maximum, which is the lowest y value on the graph, and then a local maximum minimum, which is, within the graph, are there any what we would informally call peaks and valleys? They're not the absolute highest part of the graph, but they are locally the highest part of the graph. And you'll talk in calculus or AP calculus about how to actually prove that is the case. But right now, we'll just look in the graph. So your absolute maximum, if you notice the arrows, they go up forever, right? So there is no absolute maximum. So we're going to say that it does not exist. Absolute minimum, same thing. You see the arrows go down forever. Your absolute minimum does not exist, right? So that's pretty straightforward. We have arrows going up and down, so there is no absolute maximum. But there is, however, if you look right here, think about if you see a local maximum or minimum. You're welcome to pause the video at any point to think about it, to take some time to see if you can figure it out and restart. But it's right here, right, at -1. So there is a peak, right? We're looking for peaks and valleys. So there's a peak, right, where the graph changes from increasing to decreasing right here at -1. So there is a local maximum at -1. All right. I hope that video helped you with characteristics or properties of functions. Definitely email me if you have any questions.